Hello everyone. Today we continue building our dungeon crawler game. Where we left off last time is that when you run the game, you can move up the stairs and reach the target and go into the win state, and that's it. Um, I think it would be nice to at least be able to show where the target is. And it's also a good excuse to show what I do to get models ready for use in RealityKit. So, as mentioned earlier, we use the Dungeon Remastered kit, and that one has it files in multiple different formats, and I'm using the GLTF format because these contain both the the materials, textures, and model all in a single file, so they're pretty easy to use with. And I think there should be a chest here somewhere that has some gold in it. I'm using Blender because it's a free 3D modeling application, and I start by getting everything outside of the scene by clicking things and then pressing X. And then I need to import the file that I need. So I think it's somewhere in downloads. And then there should be a chest with gold here somewhere. So this is the thing. If you want to see how it looks shaded, you can click here on viewpoint shading, and then you can also see it. How more or less how it will look on the screen. The first thing I want to do is I want to have an open chest. So you can look at the lid, and I can press R to rotate, and then X to rotate around the X-axis and just open it. So now I have an open chest. And I should scale it down by pressing S and then type in 0.25 for the entire thing. I'm sorry. S for scale and then 0.25. So it's a lot smaller, but now it's in the same scale as all the other models. And if we would do it like this, it would show in the sort of floating around. So I also need to move it down a bit. And we can do that by typing P for grab, I guess. And then Z for the Z axis, and then minus 0.5. And I should now have a model that is more or less in the usable state. I now need to apply all these changes, all these transformations. And to do that, I do Command A, and then I do apply all transforms. And now I should be able to export this as a universal scene description. So it's a bit of a convoluted process, so I need to save it somewhere. I'll call it target.usdc. Export it. Now we open Reality Composer. First time you do this, you should create a new project. I already had at least a project, and that's sort of where I keep all these models together. So what I can do is I can go to the folder where I saved the USDC file that's here and drag it into my project. And then I just say keep both. And then I can double click the target and I can see it here in this scene. And now I can export it from here. I create an export folder for this as a USDZ file instead of USDC file. I don't really know the difference, but I do know that for some reason RealityKit expects a USDC file. So I go to my exports, I have my target here, and now I can drag it into our models folder. And you can also look at it if you want. And now we can start using it in our game. So let's say that we have here, we render our map. Let's say we have a target. Then we will say, we'll add a child for place a model at, and it's called target at coordinate dot to sim3. And also I want to add a floor as well. So let's see if this more or less works. Should be able to go up. And now we have our chest with all the cool gold in it here. Okay. Let's quickly commit this. Okay. So far, so good. And we still have some time. So another thing I wanted to take care of is that, well, as you notice, when you reach the final place, you can still look around and still move. And I don't think that makes any sense. Normally, you should be able, once you reach a win state, I think we should stop being able to uh, 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 and to move around. So I think that's something that's worth just changing. So we have a win or lose conditions. And we should say that when the party reaches the target, they should no longer be able to move. So we need a world. We move right. Then we expect. And then we say world of move party to the left. But then we expect to still be on 1, 0, because that's where the target is. Let's see. Okay, so the expectation failed, and that makes sense. So let's go into our move party function, and the first thing we can do is we can say guard current state is undetermined, else we return. Or more specific, could say you didn't win. This might be safer going forward when we start also looking at loose conditions. Okay, so now this test passes. We can quickly solve that warning. And I think the same should apply to rotating. Now let's do something similar for rotating. So no longer be able to turn. So we say world dot turn clockwise. That's fine. So they were facing north. They should still be facing north. So let's go into a world. We'll need more or less the same guard for turning as well. So this one passes. And we now notice that we're doing the same check 3 times in each of these functions. So the first thing we could do is extract the conditional. For now, I'm going to note it in our tech depth. What contains 3 times the same check for movement and turning. Because it's now, we repeated it now 3 times, we should look at a way of extracting this or abstracting away from this. So in terms of do not repeat yourself, this is the moment to start looking at it. What we could do is we could extract this one and the conditional. I don't know, is this possible here? Oh, we can do it too. It wasn't exactly what I expected, but not completely crazy. Also, what if we say can execute, can perform action? But what I really wanted was a computed property. And it can be private. So I can use this one every time. I could also extract this one. So let's say we call it perform movement. Run the test and see if they still pass. Yes, they do. I'll put them below all these other ones. And now, as you notice, these 3 look very, very, very similar. I'll quickly commit. And now we can start looking at how do we want to tackle this. So the only thing that's different is the final action that is performed. And it's sort of a hint that we are looking at a command pattern. So what if we had, let's go down and say we have an enum party command. We have a case to move to a direction. We have a case turn left, and we have a case turn right. And we now say we have a function called perform. This will take a command. And this one will first do the can perform action, and then, depending on the type of command, We'll add all cases. We do the move party into a direction. We do turn counterclockwise. We do turn clockwise. Okay, so we added some additional stuff. Now let's make move party private and see everything that breaks. Here we can no longer use it, but we can use the, instead of this, we can use the perform move forward and something similar for the other ones. So we need to swap these around. In some tests, this also needs to change. It needs to change because we're changing the API from the outside. Let's see how many more there are. Fortunately, there's quite a few. So it's a bit of a chore. Let's see how many more there are. Oh, this is about staircases. Let's see if the tests now pass. Okay, so they pass. So we have movement now uses party command. And let's go back into our world. Let's do something similar for the. We should now also be able to take this one away. That's still pass. Party no longer need to check state. And now this move party function only has to perform movement function. You can inline this, although this is in Xcode and not a built-in refactoring, so we need to do it manually. But this should also still pass. So we inline form movement. And now we do the same for turning. So we mark this one private. We see every place that now requires a change. Also, I'm going to use the same names. Turning left will be turning counterclockwise, and turning right will be turning clockwise. Okay. So now we can turn clockwise. There should also be some tests that are reliant on this. Okay, so the test passes. So git commit turn clockwise and now uses command. Then we can go into our world. We can make sure that we no longer need this guard statement. So clockwise no longer needs a guard statement. And finally, we can do the same thing for turning counterclockwise. So it's the same recipe. We may mark it private. We see what breaks. There's probably a couple of tests that also use this one. Okay. Now the test passes. So we can say git commit to counterclockwise uses command. We go into our world. We get rid of the guard statements. Run the test. And that's that for that refactoring. So we can go. We cleaned up the don't repeat yourself in the world by having first a check to see if you can actually perform a certain command. And the interesting thing is that over time we can, of course, add additional commands. And of course, we can make this can perform action function also a bit more smarter in terms of what it can check for. We could also, instead of the commands being in enum, use polymorphism to change its behavior, have the command itself contain behavior. That's a bit much for now. I'd say let's keep that, add that when it's needed. But for now, this seems to be looking pretty well. I think it would make sense to have these more or less in the sequence that they are checked for in the switch statement. Um, in sequence methods. Okay. So today we did two things. We made sure that we can see the treasure, and when you reach it, you can no longer turn around and so on. Um, Staring at this blank wall is a bit boring, and that is something we will fix, but that's something for another time. Thanks for watching, and have a great day.